Morning, students. Good morning, students. Welcome to the first unit of high voltage engineering. First unit, it covers over voltages in electrical power system. In this unit, we will discussing about the causes of over voltages and its effect on power system, lightning, switch surges and temporary over voltages, reflection and refraction of traveling waves, protection against over voltages and insulation coordination. In this class, we will be discussing about the first topic, over voltages in electrical power systems. Already we have studied power system analysis and power system operation and control near lower semesters. So, the prerequisite for this course is power system analysis. To start with, let us refresh what we have studied in power system. A power system consists of generation, transmission and distribution system. The generating system consists of energy sources. The prime mover may be hydraulic turbine or a steam driven turbine or internal combustion engine. So the electric load on system may be lighting load, heating load or a motor load. High voltages are used in transmission, so we should generate high voltage. So we have to measure such high voltages. Hence, we need high voltage and current measuring devices. The causes of over voltage, lighting phenomena, the charge formation of lighting, rate of charging of thundercloud, mechanism of lightning strokes, characteristics of lightning strokes, and the factors contributing to good line design, protection afforded by ground wires, tower footing resistance, interaction between lightning and power systems. The general applications of high voltage are they are utilized in cathode ray tubes, particle accelerators, xerography, spray painting, electrostatic precipitators, ignition in internal combustion engine, gas discharge lamps. To meet the increasing demand for electricity, large power stations are built for efficient utilization of water power, conventional fuel. Nowadays, 1000 megawatt is being generated by a single power station. To start with, let us see the causes of lighting. Lightning phenomena occurs due to the peak discharge in which charge accumulated in the cloud into the neighboring cloud or to the ground, and electrode separation cloud to cloud or cloud to ground is about 10 km or more. The positive and negative charges, they become separated by heavy air current with ice crystals in the upper part and rain in the lower region. Charge separation depends on height of the cloud, which may be at 200 to 10,000 meter. Charge centers at a distance of about 300 to 2 km. Charges are formed in the cloud. So charge inside the cloud is 1 to 100 coulombs and the cloud potential is very high, 10 to 7 to 10 power 8 volt, and the gradient with the cloud is 100 volt per centimeter. A gradient at initial discharge point is 10 kilovolt per centimeter, and the charges formation in a cloud are shown in this figure. So the mechanism of lightning flash occurs. So pilot streamer and a stepped leader, a ground streamer and return stroke and subsequent strokes occur. So the characteristics of lightning strokes are current time characteristics, time to peak or rate of rise, probability distribution of current and time, wave shapes of lightning voltages and current, short front time and tall time. Surge voltages, the maximum surge voltage in a transmission line is 5 megavolt. Most of the surge voltage is less than 1000 kV online, and the front time of 2 to 10 microsecond and a tall time of 20 to 100 microsecond. The rate of rise of voltage is 1 megawatt per microsecond. So direct strokes, they are directly discharged on the transmission line or line wires induced stroke. Cloud generates negative charge. At its base, the earth object develop induced a positive charge. So over voltage due to the switching surges, the making and breaking of electric circuits with switchgear may result in abnormal over voltages in power systems having large inductance and capacitance. Over voltages may go as high as 6 times the normal power frequency voltage. In circuit breaking operations, switching surges with a high rate of rise of voltage may cause repeated restriking of the arc between the contacts of a circuit breaker, thereby causing destruction of the circuit breaker contacts. Switching surges may include high natural frequencies of the system, a damped normal frequency component, or restriking and recovery voltage of the system with successive reflected waves from termination. And the control of over voltages due to switching occurs. Energization of transmission lines in one of the most steps by inserting resistance and withdrawing them afterwards. Phase control, closing of circuit breakers, drainage of trapped charges before reclosing, use of shunt reactor, limiting switching surges by suitable surge. And the overvoltages can be protected by minimizing the lightning overvoltages are done by suitable line designs, providing guard and ground wires, and using surge diverters. And the protection against overvoltages, shielding the overhead line by using ground wires above the phase wires, using ground rods and counterpoise wires, including protective devices like explosion gaps, protector tubes on the line, and surge diverters at the line terminations and substations. Thank you, students. We shall see the next topic in next class.